So under the IC technology, you will be having transistor technology, IC technology, and then to microcontroller technology. So IC is built up of transistor. So your microcontroller is made up of ICs, many IC. Okay. So that conversion only they are given here. So every processor must eventually be implemented on an IC. You all know. So a processor is made up of IC only. So IC technology involves the manner in which we map your digital, that is gate level implementation into IC level. Okay, gate level to IC level, that is IC technology. So IC is nothing but integrated circuit, which will be called as a chip. Okay, single chip, which is a semiconductor device consisting of a set of connected transistor and other device. So integrated circuit will be having more number of transistor. It may be lakhs of transistor. Okay, in a single IC you can uh, implement. Okay, in a single semiconductor chip. Okay, so a number of different processes exist to build semiconductor, the most popular of which is CMOS. Okay, so you are having different semiconductor process, but among that you'll be using CMOS technology, that is complementary metal oxide semiconductor. You will be using both PMOS and CMOS in a single process itself, that is said to be CMOS. Okay, so the IC technology will be differing from the customized IC for a particular implementation. Okay, you can differ the customization IC in the IC technology. So for lack of a better term, so we can use the same technology, that is term for the technology as IC technologies. Okay, which will be independent from processor technology. So there you will be using any type of processor which will be mapped to the technology. Okay, but here we are going to use the IC level, that is gate level technology. Okay, anga processor type of processor, but here gate IC, what type of method of implementation we are going to use. Okay, that will be explained here. So to understand the difference among the IC technology, we must first recognize that semiconductor consists of numerous layer. So IC technology la, you will be learning first the semiconductor implementation, that is how the semiconductor layers are formed in the IC. So you'll be having three layers. So the bottom layers will form the transistor. Okay, in your IC you will be having three semiconductor layers. First layer, bottom layer. So the bottom layer will form the transistor, then middle layer will form the gate, logic gates. Okay, and or XR not, likewise. So transistor na patina, it may be NPN, PNP, or FET, MOSFET, anything else. Okay, so the top layer will connect all these gates and transistor through the wire. Okay, third last layer, that is upper layer only, will connect all the devices. Okay, so one way to create this layer is by depositing. So how you will be creating this layer means by depositing the photosensitive chemical on the semiconductor surface. Okay, chip surface is nothing but semiconductor surface. Okay, so semiconductor using most type of semiconductor used here is silicon. Okay, rarely you will be using germanium. So and then shining light through the mask to change regions of the chemical. So in that layer you will be placing the mask. Okay, shining light through the mask. Mask is nothing but your layout, your design layout will be placed on that layers. Okay, as our need. So a set of mask will be called as a layout. So a narrowest line that we can create on a chip will be called as a feature size. So in the IC technology, we will be seeing the two types, that is three types, that is full custom VLSI, semi custom VLSI, and then third one is PLD. Okay, so first we are going to see the full custom IC technology. So other name for full customized IC technology is VLSI design. Okay, so in a full customized IC technology, we will optimize all the layers of our particular embedded system digital implementation. So, such optimization include placing the transistor to minimize the interconnection length, sizing the transistor to optimize signal transmission, and routing wire among the transistor. So here fully customized IC technology la moon layer me implemented you will be getting. Okay, so இதில் you will be interconnecting the wires by as our needs. Okay, so once you are getting the IC completely from the manufacturer, then you will be designing as your task. Okay, so what you are going to design, based on that you will be designing that layers. Okay, so once we complete all the mask, that is layout, we send the mask specification to a fabrication plant. Okay, ஸோ லேஅவுட் கம்ப்ளீட் பண்ணதுக்கப்புறம் லேயர்ஸ் வந்து நீ த்ரீ லேயரும் கம்ப்ளீட்டாக முடிச்சதுக்கப்புறம் தான் அந்த ஐசியே வாங்குவேன். ஐசி வாங்கினதுக்கப்புறம் வாட் யூ வில் பி டூயிங், you will be modifying the layout, okay, based on your task. So after doing the layout, you will be sending that layout to the fabrication plant, okay, to build the actual IC. Okay, so இதுதான் full custom IC design. So this other name for full custom IC design is VLSI design, very large scale integration design. So இங்கே பார்த்தீங்கன்னா இந்த சிஸ்டமில் NRE cost will be very very high. NREங்கிறது additional cost. Okay, additional cost other than unit cost. Okay, that will be very very high, and then it will be taking months to complete the design. Okay, so design level தான் நம்ம பார்த்துட்டு இருக்கோம். We are not talking about the fabrication level. Okay, only this is designing. Okay, full customized design, IC technology design, embedded design. Okay, so before the IC becomes available, it will be taking more time to complete, and but it will yield excellent performance. Okay, so the output will be very excellent with small size and power. The power and size will be very compact. Okay, so it is usually used only in high volume or extremely performance critical applications. So this type of design will be used in the critical applications. Okay, efficiently critical performance. Next, semi-custom ASIC. So here gate array will be used. Gate array or standard cells will be used. So இதில் பார்த்தீங்கன்னா full all the layers will be utilized. Okay, after designing all the layers in a chip only, you will be designing a layout. Okay, your layout. பட் இங்கே பார்த்தீங்கன்னா செமி கஸ்டம் ஆசிக்கில் பார்த்தீங்கன்னா அப்ளிகேஷன் ஸ்பெசிஃபிக் ஆசிக், தட் மீன்ஸ் த லோயர் லேயர்ஸ் alone will be built. Okay, lower layer means that middle layer and bottom layer alone will be completed. Okay, so upper layer வந்து connect ஆயிருக்காது, முடிச்சிருக்க மாட்டாங்க. அப்போ வந்து நீ என்ன பண்ணுவ, அந்த upper layer you will be utilizing for your design. Okay, so you will be designing that connection of transistor and gates. Okay, பட் அங்கே ப்ரீவியஸ் டைப்பில் பார்த்தீங்கன்னா அதெல்லாம் கம்ப்ளீட் பண்ணி தான் யூ வில் பி கெட்டிங் தட் IC. So in that IC you will be you will be making that layout based on your task. Okay, பட் இங்கே அப்படி இல்லை, டிரான்சிஸ்டர் கேட் லெவல் மட்டும்தான் அங்கே பில்டடாக இருக்கும், இன்பில்டடாக இருக்கும். பட் யூ வில் பி கனெக்டிங் ஆல் த டிரான்சிஸ்டர் அண்ட் கேட் லெவல்ஸ். ஓகே, அதனால தான் இதுக்கு நேமே கேட் அரே அண்ட் ஸ்டாண்டர்ட் செல். ஓகே, so the remaining task is to connect these gates to achieve our particular implementation. Okay, in a standard cell technology, logic level cells such as AND gate or AND or invert combination. Okay, standard cell technology is nothing but or a particular array of gates will be having. You will be designing the array with any combination. AND or இருக்கலாம் இல்ல AND or invert இருக்கலாம் வெறும் AND கூட யூஸ் பண்ணலாம். Okay, in this manner you will be designing by your hand. Okay, so thus but the remaining task is to arrange these portion into complete mask for the gate level and then connect to the cells. Okay, so the remaining task is nothing but this particular gate of array will be connected together for completing your full layout. Okay, in the gate level manner. ASIC are by far the most popular IC technology as they provide for good performance and size. So size and performance will be good here, and then NRE cost will be very less compared to the full custom IC. But in full custom IC, NRE cost will be very high. இங்க வந்து NRE cost வந்து ரொம்ப கம்மி. Okay. So this is the PLD semi-custom, full custom comparison given here. So the particular parameters will be good for particular cases. See here in the general providing, that is general processor or general technology இந்த மாதிரி டிசைனில் யூஸ் பண்ணினா what will be the advantage? It will provide flexibility. NRE cost will be very low. Time will be given for prototype. Time to market also will be available. Cost also will be very minimum. Okay, for the general providing improved system design. Okay, it is customized na based on the task you will be designing the single unit. Okay, in that case the power will be very efficient, the consuming power will be very low, performance will be very effective and efficient, and then size will be very very low, that is compact size, and then cost will be very high. Okay, this is the customized providing improved design qualities. Okay, ஸோ இதில் வந்து என்னென்ன ப்ராசஸர் யூஸ் பண்ணுவீங்க, இது வந்து ப்ராசஸர் லெவல் டிசைன், இது வந்து பார்த்தீங்கன்னா ஐசி டெக்னாலஜி used in the embedded system design. Okay, PLD semi custom, full custom. Then PLD. So next IC technology is PLD, programmable logic device. So programmable logic device technology, all layers of semiconductor will be already existing in the IC. So just we will purchase the IC and we will be implementing a programmable circuit. So programmable circuit is nothing but software through the system desktop computer. You will be designing a software program for running that particular IC. Okay, so what connections should be made between the IC and gate? Okay, that will be provided by the designing program in the computer system. So whether you have to connect the gate or not by giving 1 or 0. Okay, digital value 1 or 0, set, reset, இல்லைன்னா blowing the fuse. இங்கே கொடுத்துருக்காங்க example, blowing a fuse or setting a bit in a programmable switch. You may connect or destroy the connection between the wire and gates. Okay, that is the programming, software programming. Okay, this will be done in the IC technology PLD type. Okay, programmable logic device is nothing a programmable in a way you are going to create a software program for the logical devices. Okay, so small device which will be called as programmer will be connected to a desktop computer can typically perform such programming. So desktop computer only going to perform program for the logical device. Okay, so here we are going to divide the PLD into two types. One is simple and another one is complex. So under the simple type you have two further types, that is PLA and PAL. So PLA ங்கிறது programmable logic array, PAL ங்கிறது programmable array logic. Okay, logic arrayக்கும் array logicக்கும் difference இருக்கு. So logic array ல பார்த்தீங்கன்னா you will be having two types of logical array. One is OR gate array and another one is AND gate array. Programmable array of AND gate and programmable array of OR gate. These are the two types of programmable logic array. ஒன்றும் இல்லை, AND gate will be in the array manner, OR gate will be arranged in the array manner. Okay. Then PAL. So here in PAL, you will be reducing the expensive programmable components. Here you will not be using all the arrays. Okay, AND array, OR array, like that. Cumulatively, you will not be using. So complex, simple array பார்த்தீங்கன்னா PLE and PAL, but complex type is well good example FPGA. Okay, nowadays you are using very popularly that FPGA. Okay, so field programmable gate array. So here the connection will be among the logic blocks. Okay, array கிடையாது, gates of array கிடையாது, and array or array கிடையாது. or array and array யூஸ் பண்றது தான் simple method, that is PLE and PAL. But here in field programmable gate array, you will be using logic blocks. Block of blocker you will be connecting. Okay. But in PAL and PLA, you will be using array of logic. So this type of FPGA logic will be implemented for more complex designs. Okay. Here the PLD offer very low NRE cost and almost instant IC availability. However, they are typically bigger than ASIC. Okay, PLD. PLD will have low NRE cost, means additional cost will be very low. Okay, but ASIC is nothing but application specific integrated circuit. The unit cost will be very higher for that. Okay, it will be consuming more power. Power consumption will be very high. Consumption will be very high, and then process will be very slower. That is in FPGA kit. They still provide reasonable performance, though so are especially well suited to rapid prototyping. So the performance of FPGA will be very efficient and effective. So this is top down design process of embedded system design. So four process will be involved in the top down design process. That is, first one, system specification, behavioral specification, next one RT specification, logic specification. RT is nothing but register. Okay, register, R stands for register transistor specification. So system specification is nothing but you are thinking what you are going to design, that will be converted into an program. Okay, or a group of instruction will be designed for forming a particular task program. Okay, that is system specification. And then behavioral specification is nothing but the program will be converted into the some we will be